Hey there, sixth grade. Good morning. Okay, we have a short lesson today because I think you guys have kind of already got the hang of volume. But this is kind of interesting because it shows you that there's another way to think about the formula in this lesson. And I think you guys all at this point know that volume is length times width times height. And we've only been working with rectangular prisms. That's all we've done so far. And this will always work, okay? Every prism, every rectangular prism has 3 dimensions. We can call one of those dimensions length, one of those dimensions width, and one of those dimensions height. You multiply all 3 of those together and you get your volume, and it's always in cubic units, okay? So let's just look at these 3 prisms right here. All right, maybe I should zoom in a little bit. I don't know if you can see real well. It looks slightly blurry to me, but it says write a numerical expression for the volume of each of the rectangular prisms. So I've done that, okay? I've just taken the length, which is 15 inches, times the width, which is 1.5 inches, times the height. Okay, then I did the next one, same way, length, width, height, length, width, height. Here, so look at these expressions for a second. What do you notice that they all have in common? There's something the same and there's something that's different. And this is a really important question to ask yourself when you're studying math. You're looking for structure, you're looking for patterns. What is the same and what's different in each of these expressions? Hopefully you all notice that they have the same length and width, 15 by 1.5. The bottom of the prisms are all the same, 15 by 1.5. So they want us to rewrite the expressions now to show what they have in common. So I did that here. 15 times 1.5 is 22.5 square inches. So first prism could be 22.5 inches squared times 3 inches. The next one, 22.5 inches squared times 6 inches. And the third one, 22.5 inches squared times 9 inches. So now the next question is leading us a little further. If we know the volume for a rectangular prism as length times width times height, which we do, what is another formula for the volume that we could use based on these examples? Well, clearly, if we have the length and the width, we can find the area of the bottom of the box, that face that the box is sitting on. And we can call that the base. And if you just find the area of that rectangle, because that's what length times width is, right? If you just find the area of that bottom of the box, the face that is the bottom of the box, and we can call it the base. If you know that, all you have to do is multiply that area times the height. That's cool. This formula here, where volume equals the area of the base times the height, is used for many other prisms, okay? And a variation of this will be used for many other solids that we won't get into until later grades. But so what is the area of the base? Well, 15 times 1.5 is 22.5 square inches, okay? Now we're going to calculate the volumes of these prisms. I've already done it here, prism 1, 2, and 3. You need to do it as well, okay? Don't just copy. I know some of you are doing that. It's going to be much more beneficial for you to do this work yourself. I'm explaining it to you in case you have questions, but I need you to go through the process of doing the work so it helps get implemented into your brain. So this prism 1 is the area of the base times the height. Here's the volume. See how the area of the base is all the same on these, but the height goes from 3 to 6 to 9. So the volumes increase as well. Now they're just going to ask us to take another look at how the volumes of the first and second prisms compare. So look at this number and look at that number. Now, when they're saying how do they compare, let's say something a little more interesting than this one's bigger than that one, okay? Let's try to divide 135 by 67.5 and see if we can find how much bigger. You see that it's 2 there? I divided 135 by, I divided the volume of the second prism by the first, and I got the number 2. That means that this is twice as big as this. 135 is twice 67.5. So that's what I wrote. Prism 2 is 2 times larger than prism 1 because the height is 2 times larger. Look at the height. The base of the area of the base is the same. So the only thing that changes is this height. And since 6 is double 3, the volume is double. All right. Same thing for when you compare prism 1 to prism 3. The volume of prism 3 is 22.5. And if we divide that by 67.5, we get 3. So we could say the volume of this is 3 times the volume of that. And look at the height. Obviously, 9 is 3 times 3. So very cool. We're looking for patterns. We're looking for relationships. That's what we do in math. Okay, the base of a rectangular prism has an area of 3 1/4 square inches. Area is always measured in square inches, okay? Keep that in mind, square inches. The height is 2.5 inches. Determine the volume of the prism. So we're going to use our new formula where we just take the area of the base, which they give us is 3 1/4 inches squared, area of the base times the height, which is 2.5. And then we multiply those together and we get 8.125. That is 8 1/8 cubic inches. Okay, because square inches times inches is cubic inches. All right, another pattern there. Think about exponents. Okay, for square inches, we're looking at an exponent of 2, right? For regular linear, oh, I just froze, didn't I? All right, I think we'll just call it a day, people. You guys go ahead and do the extension yourself. You got this. Come to office hours if you have questions.